process capability that I'm excited to discuss with all of you today is AFP, or automatic fiber placement. So in combination, this was done out of our Switzerland facility. We have an R&D facility over there. So in combination with a local university, HEIG, VD, as well as a Swiss program, InnoSwiss, they developed both the hardware and the software to create unidirectional reinforcements for the compression molding of the DLF parts. So you can see an image of this robotic head. It has the capability to lay unidirectional tape, so the same tape that we're using, like an AS4 peak-based tape, unidirectional tape. They have the ability to do complex geometry preforms that would either go inside the tool, or we can actually lay it on the exterior of the part. So what we did is we started off, optimizing the process. We want to understand, they built the laser from scratch too, so they want to understand, the optimal laser, the feeds, the times, the best way to apply that material onto the exterior of our already molded plate, if you will. So we started off with coupons, simple demonstrator elements, and then we moved to 3 parts. What you see here too, and I know there's a lot of numbers here, it's kind of tough to read, but the message of this slide really is that we were able to take a plate, a discontinuous long fiber plate, apply this unidirectional tape onto it, and then we're able to achieve 75% of that baseline of the U tape, so 67 MPa, which is phenomenal. The project charter, the intention was to achieve 50% of the strength, so we're actually exceeding that. And then from a financial perspective, a cost perspective, we wanted to we didn't want to increase the price by 50% either. So we've succeeded in surpassing that as well. I've got a few more details on the next slide about that, discussing some of the activity associated with parts themselves. So we chose 3 different demonstrator parts. In addition to some of the coupons, you can see a bearing response up there in the top right-hand side. But what we saw is we're going to be, it's not the right solution for every part, right? So it's going to be geometrically dependent. But if we take the part on the right-hand side now, the bearing loading direction, we've got an insert right now for unidirectional tape as well. It goes on the outside surface of that component. We were able to increase the strength of that bearing pull-out by 61%. So just pure DLF, it starts off with 17.5 kilonewtons, saw failure increase to 28.3 kilonewtons with only a volume fraction of 2.5% unidirectional tape. So again, this exceeds the targets initially set forth by the charter. And there's honestly 0 weight penalty too. We're using the same material, it's replacing it volumetrically. But like I was saying, not all DLF parts can be efficiently reinforced. We did have some parts that did not quite meet that, but that was part of the learnings, understanding how to apply it, where to apply it. We want to make sure that we're able to fully understand that. So this is something that actually is going to be presented in an upcoming conference by my colleagues, Nick Weibel, at ITEC. It's a conference in Europe coming up, I think in 2 weeks or so. And I've linked his presentation, his paper, as a resource for this presentation. So if you're interested in learning more, please reach out or go listen to his presentation in the coming weeks.